All right, so I think this is recording. Let's solve this quadratic inequality. It's already compared against 0. We don't see any greatest common factor. So let's come in and use our x method to factor it. Our middle term is 5x. Our first times our last is negative 6x squared. And, excuse me, we need two expressions that when multiplied together give us the top expression, but when added give us the bottom. We want to now proceed in a table because our leading coefficient is not 1. So we can't use the 6 and the negative 1 directly. We come to a table. We put the first and the last along one diagonal, and the values that we found in our x along the other diagonal. And now we factor both horizontally and vertically. Both of these numbers are even. They're both divisible by 2. These are both negative values. These both have an x. These both have a 3x in common. So this expression factors the x plus 2 and 3x minus 1. So if I set each individual factor equal to 0 and solve, that divides my number line into 3 regions that I'll label A, B, and C. X plus 2 gives us a negative 2. 3x minus 1 gives us a positive 1/3. So let's proceed in a table. I'm going to write my table over here just to give myself some more room. I'm going to label my first column test point. My middle column, I'm going to use my factored form of my inequality. I could use the original inequality. It's just usually easier for me on arithmetic to use my factored form. And then I'm going to have a column that I call the truth column. So from region A, I need a test point. A number that is smaller than negative 2 is negative 3. So I'm going to pick it as my test point for that region. Replace x with negative 3. Then I'll have a negative 1. Negative 9 minus 1 is a negative 10. But a negative times negative is positive, and a positive number is not less than or equal to 0. That's a false statement. So I'm not going to shade in any values in this region. So a nice test point that is between negative 2 and positive 1/3 is 0. And if I replace x with 0, I have 2. 3 times 0 is 0 and negative 1. Positive 2 times negative 1 is negative, and negative numbers are less than or equal to 0. That's a true statement. So I'm going to shade in that region. Now I just realized that I forgot to circle my critical points. Because my inequality is not a strict inequality, because I have it underlined there, I'm going to include these endpoints, my critical points, in my solution set. And I just determined that I was going to shade in the ones in B. And if we look at region C, pick some number that's greater than 1/3. Well, I'm going to pick 1, because 1's easy to do arithmetic on. 1 plus 2 is 3. 3 times 1 is 3, and 3 minus 1 is 2. But 3 times 2 is 6, and 6 is not less than or equal to 0. That's a false statement. So I'm not going to shade in any point in region C. So this is a picture of my solution set. I want to present that as an inequality. So I have negative 2 is less than or equal to x, which is less than or equal to 1/3. And that's my final answer. So don't be afraid to ask questions. I hope that helps, and I will talk to you later. Bye.